Fire safety on board. Fire is one of the biggest threats on board ships. If fire is not detected on time, it could have disastrous consequences. As a watchkeeper, it is your responsibility to take necessary precautions to prevent fire on board. On completion of this topic, you will be able to explain the fire chemistry, recognize the fire hazards, describe how fires start and spread, state the various classes of fire and their firefighting methods, describe how ship structures are designed to prevent the spread of fire, explain fire alarm systems, fire detectors, and fixed fire extinguishing systems, identify portable fire extinguishers, and realize the shipboard firefighting organization. Fire is an oxidation process. During this process, a flammable substance combines with oxygen in the presence of heat energy to give off heat and light. When any one of the elements is absent, the fire extinguishes. The fire triangle. Fuel, heat and oxygen are the three components of fire. Fuel refers to any combustible solid, liquid or gas. Heat refers to energy capable of starting combustion. The source of heat energy can be a lighted fire, static electrical discharge, short circuit, heat arising from metal to metal contact, without lubrication, and so on. Oxygen is present in the atmosphere and its percentage is 21%. The fire does not spread when any one of these three components is absent. Ignition phase. When there is sufficient air-vapor mixture and the temperature of the substance exceeds its ignition point, the fire starts. This fire can be due to an external heat source, autoignition, or spontaneous ignition. Spontaneous ignition occurs when certain materials become warm during oxidation, producing more heat, which accelerates the oxidation process. In the ignition or incipient phase, heat flows back to the material due to radiation. It results in a chain reaction, enabling the components to sustain fire. Developing phase. During the developing phase, the flame spreads on the surface of the material. After sufficient heating, it gives off vapors which act as the source of heat. Solids and liquids convert to vapor state before combustion. In case of flammable gases, there is a high risk of explosion because the combustion process takes place at an extremely fast rate. The burning speed depends on the rate at which the heat source gives off the vapors and its combustibility. Petrol has a very high surface burning speed, while wood has a low surface burning speed. Absolute fire phase. In this phase, the heat spread on the surface of the material penetrates into the depth of the solid or liquid. Intense flammable vapor will be generated at this stage. Burning out phase. The fire continues to burn until it consumes most of the vapor. In the burning out phase, most of the fuel gradually burns out and the fire dies thereafter. The fire tetrahedron. The base of a fire tetrahedron represents the fourth component in a fire triangle. It is the chain reaction due to the molecular combination of fuel, oxygen and heat energy. When you break the chain reaction, fire does not spread. Halon gas has the capability to stop the chain reaction in microseconds. These gases are also known as vaporizing liquids. Halogenated hydrocarbons BCF, halon 1211, and BTM, halon 1301. BCF has low vapor storage pressure and hence its containers are lightweight and 40% more effective by weight than carbon dioxide. Halon type extinguishers are suitable for Class C and Class D fires. Halon is not used nowadays because it destroys the ozone layer and is not environment friendly. All materials are not flammable. Even flammable materials require certain conditions conducive to burn.